Okay. Uh, am I audible, sir? Or my screen is visible clearly? Hello? Okay. Okay, so in today's video I will follow one book. We will try to discover a few things about Laplace transformation, and I will follow the book by Dennis G. Gill. It is a very nice book, and this is in chapter 7, the Laplace transform. So just I'll discuss a very few preliminary things. Then I have 10 to 20 problems. We will discuss those problems mainly. So I will discuss the theory part in a quick session for 30-35 minutes. Then I will go to the problems. So Laplace transformation is basically a special type of integral transformation. Now what do we do by saying, what do we mean by saying integral transformation? Consider this integration 1 to 2 2x y square dx equal to 3y square. This 2x y square dx equal to 3y square. Okay, so if you integrate over this 2x, you integrate over this x dx, so that will be, it will be x square, and if you x square you put the limit, then it will become 2 square minus 1 square will be 4 minus 1 will be 3. So this is 3y square. So what is we say here? Now similarly, if you have this sort of integration, you have a function ft which is a function of t. So mostly here the dependent variable are written as t. Why? Because mostly the theory of Laplace transformation or Fourier transformation, they evolved with the growth of differential equation in physics, and in mostly the physics the kinematic laws are defined based upon the t. For example, you have some differential equation, and in differential equation you have some dependent variable and some independent variable. So when you try to determine the trajectory of the state evolution of the dependent variable in terms of the independent variables, we mostly express that in terms of physical problems in terms of time. For example, velocity in terms of time, displacement in terms of time. So here also for generic convenience we will use t as the independent variable. Now if you just integrate a to b ft dt, so that will be a definite integral, right? Because if ft is continuous, and then you can have some capital ft such that df dt equal to small ft, and by fundamental theorem of integral calculus you can represent it in terms of a capital fb minus capital f. Now what will happen if instead of integrating over a to b ft dt, if we consider a function kst, here this t is of that independent variable t, because integration is carried over on t, and then s is some another, we call it as some parameter argument. Okay, this is called some parameter argument, because depending upon this s, because if you integrate it over a to b, instead of t you will get a comma b the function, and then the final expression will contain the variable s. So this parameter variable will determine the ultimate transformation, and obviously that will be a function of s. That integration, the resultant integration will be a function of s. So we are particularly interested in integral transformation where the interval of integration is the unbounded interval 0 to infinity. Why 0 to infinity? Once again here you can consider that this s is nothing but it also represents the time argument in some another domain. Okay, so that's why the logical argument is to keep this a comma b in terms of a b, because we want to consider the integral over half of the real line. If ft is defined for t greater than or equal to 0, then the improper integral 0 to infinity kst ft dt is defined as a limit integration 0 to infinity kst ft dt limit b tends to infinity 0 to b kst ft dt. So this is how, if the limit 1 exists, we call, and we know that these type of integrals are called improper integrals, right? These sort of integrals we call them as improper integrals. Why improper integrals? Because in there are two sort of improper integrals. This is a improper integral of the first kind, because one of the limits is infinity, and we know that infinity is not a real number. If the limit 1 exists, we say that the integral exists or is convergent. If the limit does not exist, the integral does not exist and is divergent. The limit 1 will in general exist for only certain values of variable s. So that parameter s will determine this parameter variable, or you can call driver variable. This parameter variable s will decide whether the integral converges or not. Now this function kxt is called a kernel function. This variable is called a kernel function, and I was searching for notes for this problem, and there are also good amount of video available from NPTEL. NPTEL, there is a special I think a special course they run on integral transformation, and also there is a lecture video uploaded by Professor Indrabo Roy of IMSC Chennai. You can also watch those videos, they are also very nice. So you can also watch those videos. Here you can just get those videos that are also, like, I am just this is the link, Professor Indrabo Roy. You can watch his videos also. It is very well, this Laplace transform course. This is also a very nice, where you can get many sorts of problem and all, and this is also, you can go through this course also. These videos are freely available on NPTEL. There are probably 420, I think 20 lecture videos are there. So you can also watch those videos also. So okay, now Laplace transformation, the definition is like that. Let f be a function defined for t greater than or equal to 0 within the integration Laplace of ft 0 to infinity e की power minus st ft dt is said to be the Laplace transformation of f provided that the integral converges. So the kernel function, if we fix the kernel integration as e की power minus st, now there is a few particular properties of e की power minus st such that e की power minus st is everywhere differentiable, right? E की power minus st is everywhere differentiable. Its partial derivative exists everywhere. You can construct the partial derivative with respect to s, with respect to t. Also e की power minus st is a monotonic decreasing function. As you go up to infinity, this e की power minus st converges to 0. Okay, so there are few functions whose Laplace transformation you can calculate directly, and those are very important and functions such as the sine function, the cos function, or the polynomial functions. Okay, so those functions are sine function, cos function, and cos hyperbolic, sine hyperbolic function, and e to power x function, or e to power t function also. So Laplace transformation of a function ft is integration 0 to infinity e to power minus st ft dt. Sorry, give me a second. So I just solve one problem based upon this just definition. If you have this a very basic one, evaluate Laplace transformation of 1. So what you have to do, you need to just integrate 1, you calculate you multiply the kernel function a to power minus st. Okay, so this is limit b tends to infinity e to power minus st by s 0 comma b, because you are integrating just e to power minus st dt, and then just this is limit b tends to infinity e to power minus st by s 0 comma b. You need to just put b here, so minus e to power minus sb, then this minus, and there will be minus and minus will be plus, then 1 divided by s, that will be ultimately 1 by s, because your s is greater than 0. So Laplace transformation of the function 1 exists only when s is greater than 0. So this is minus of e to power minus sb plus 1 by s ultimately gives 1 by s. Okay, so this limiting sign here, read it as, if there is this straight line 0 comma infinity, then read it as, throughout this lecture series, read it as limit b tends to infinity 0 to b, that integration. Okay, similarly, so this is Laplace of transformation of 1 is equal to 1 by s. Similarly, you can also determine Laplace transformation of t. So Laplace transformation of t will be 1 by s square. 1 by s square. Can you determine the Laplace transformation of the simple function t? Hello, am I audible? Hello? Okay, so from definition 7 we can also determine Laplace transformation of this function t, which is nothing but 0 to infinity e to power minus st t dt, and you integrate by parts using limit t tends to infinity t to power e to power minus st equal to 0 is greater than 0 along with the result from example 1. You will know that Laplace transformation of 1 is actually 1. So this is nothing but Laplace transformation of 1, so that will be 1 by s, that will be 0, so plus 1 by s into 1 by s, that means ultimately 1 by s square. So here I am giving you one result, that if you are to determine the Laplace transformation of t to the power n, can anybody tell me the Laplace transformation of t to the power n? Do you know Laplace transformation of t to the power n? Anybody? Okay, Laplace transformation of n t की power n is nothing but gamma n by t की power n plus 1. Next, Laplace transformation of e की power minus 3t. So you can also use these things, but also you can use this is actually fast translation formula. See how translation formula works. So e की power minus 3t, 0 to infinity e की power minus st e की power minus 3t dt. So this is ultimately e की power minus s plus 3 into t, this term. Okay, now you can write it as e की power minus s plus 3t into 1 dt. So that is nothing but the Laplace transformation. The Laplace transformation of 1 with respect to s plus 3. S plus 3 is now the variable. So what will be the formula? It will be just instead of s you need to put s plus 3. So that is why this is called fast translation formula, because it just shifts. So if you have there, that is 1, so that is 1 by s plus 3, that is this e की power minus 3t, e की power minus 3t, you have some variable, call it as a function, call it as ft, and for that ft you have Laplace transformation capital Fs. Now if you want to calculate the Laplace transformation of e की power minus mt into ft, then the final answer will be f of s plus m. If you know fs, then no need for calculation for this product term. You can directly just substitute s by s plus m and you will get the answer. I will discuss the translation formula, but here also and intuitively you can get the idea that what is happening out there. So this is called the first translation formula. This when you are multiplying with respect to this e की power exponential negative exponential term. Okay, there is Laplace transformation of sin 2t. So when I was in my masters, when I learned these concepts, and I used to fumble in these things. So what is happened, the Laplace transformation of sin mt, if you have sin mt, so Laplace transformation of sin mt will be Laplace transformation of sin mt will be m by s square plus m square, and Laplace transformation of cos mt will be s by s square plus m square. Okay, so in trigonometry we know that sin square theta plus cos square theta equals to 1, and in Laplace also the Laplace transformation of sin t and cos t, if you add them up you will get no sorry, no, that is not happening. So this Laplace operator L is a linear function, linear operator. That means Laplace transformation of alpha ft plus beta gt will be alpha of Laplace transformation ft plus beta of Laplace transformation of gt. So that is how you can use linearly. That is, if you have Laplace transformation of 1 plus 5t, that will be Laplace transformation of 1 plus Laplace transformation of t plus 5 into Laplace transformation of t, that will be 1 by s plus 5 by s square, because we have already determined ft. Now 4 e की power minus 3t, we have already discussed e की power minus 3t as 4 by s plus 3, and the sin 2t will be 2 by s square plus 4, so that will be just 4 by s plus 3 minus 20 by s square plus 4. So these are the few basic transformation. Laplace transformation of 1 is 1 by s, Laplace transformation of t की power n is gamma is gamma n by Sn plus 1, alternatively n factorial by s in s ki power n plus 1. Laplace transformation of sin kt is k by s square plus k square. Sin hyperbolic kt, just you need to put minus in the below part. And e ki power t, if you take Laplace transformation, it will be 1 by s minus a. Cos kt, that will be s by s square plus k square, and similarly cos hyperbolic kt, s by s square minus k square. So till now we have discussed about the Laplace continuity part. So Laplace transformation part. Now we will discuss a very basic thing, that what is actually the sufficient condition for Laplace transformation to exist. So just observe here. So this is called piecewise. So piecewise continuity and a function to be said to be exponentially bounded. So these are the two sufficient condition for a function to exist, to have Laplace transformation. See, piecewise continuity means this type of function, they have discontinuity only in this finite number of discontinuities on these edges. So what you can do, this is continuous upon this, you can continuous upon this, it is continuous upon this, and this is also continuous upon this. So that means this is piecewise continuous, because this function can be broken into piecewise parts. Those are actually continuous. Now, a function of exponential order, a function f is said to be of exponential order c if there exist constants c m greater than 0, t greater than 0, such that ft is less than or equal to m e ki power ct for all t greater than t. This is called exponential order. See, here it is ft, but there exists a finite time t such that after which this function ft is dominated by this m e ki power ct, and this function ft is called exponentially bounded, and f is of exponential of order c. So these are the two sufficient conditions. See, function t, this is exponentially bounded, this e ki power t always greater than t, e ki power t always greater than e ki power minus t, 2 cos t, 2 e ki power t always greater than 2 e ki power t, and then there is also exist which are not they are not such that e ki power t square is not exponential order. Is it clear why e ki power t square is not exponential order? Because see, your e ki power ct, this e ki power ct is actually dominated by e ki power t square. Okay, so these are the sufficient conditions for existence if f is piecewise continuous on 0, infinity and of exponential order c, then Laplace transformation of ft exists for s greater than c. This is the sufficient condition for existence. Okay, next we will discuss piecewise continuous function. Of this type of piecewise continuous function, we will discuss the Laplace transformation. So up to 3 it is 0, and from 3 it start, this point it has discontinuity, and then there is it is like that. So this is just constant 2. So first we will break it into two parts, up to 0 to 3 and then 3 to infinity. Then next we need to integrate it. Two e ki power minus 3s by s. So the Laplace transformation is of exponential order. So what is exponential order? Dekho, this is 0 up to 3, so that's why it is appearing e ki power minus 3s. In the denominator part we used to keep it like that, and for t greater than 3 this is 2. So from this type of Laplace transformation function you can also determine its inverse. You can also determine its inverse, the inverse of Laplace transformation. And as if is a piecewise continuous on 0, infinity and of exponential order on fs, then LFT, then fs tends to 0 as s tends to infinity. It is clear from this also. 2 e की power minus 3s by s, up e की power minus 3s means 1 by s e की power 3s. Take the limit s tends to infinity, that will be ultimately 0. Okay. Next there are many problems. जैसे कि this step function, this is -1, this is 1, e की power t plus 7, this sort of integrations. I will leave this exercise part. I request you to please, I have already uploaded the book and this is a very nice one. If you solve this chapter 7, you will understand, you will get the actual essence, and this book is meant for engineering students. I have a few problems, I will discuss them. Okay, so similarly we have learned how to we know how to calculate the Laplace transformation. Now we will learn try to learn that you have the Laplace transformation. Now you need to identify the function back. Now how these things can be achieved? So for that purpose you need to know inverse transforms of functions, such that Laplace transform so Laplace transformation, inverse Laplace transformation of 1 by s is 1, inverse Laplace transformation of n factorial by s की power n plus 1 is t की power n, Laplace transformation of 1 by s minus a is e की power t. And also we have already learned that if your inverse transformation, Laplace transformation is 2 e की power minus 3s by s, then your function will be ft equal to 0 up to 0 less than or equal to t less than 3 and is equal to 2 for t greater than or equal to 3. Okay, in evaluating inverse transformation, it is often happens that a function of the s under consideration does not match exactly of the form. Then we will necessary to fix up the function by s by multiplying and divided by appropriate constant, such as this Laplace inverse transformation of 1 by s by 5. I am giving you 2 minutes, just think how to do Laplace inverse transformation of 1 by s की power 5. See, this is inverse Laplace transformation of 1 by s की power 5. Just fix it with 1 by 4 factorial, or here 1 by 4 factorial. So that is 4 factorial. So that means it is Laplace transform, inverse Laplace transformation of 4 factorial by s की power 5 will be t की power 4. So this will ultimately give you t की power 4. To match the form given in D, Laplace inverse 1 by s square plus 7, you just multiply with root 7. So that will be root 7 by s square plus root 7 whole square. So that will be 1 by root 7 sine root 7t. Also, Laplace inverse transformation is linear. The combination, if you take Laplace inverse transformation of alpha fs plus beta gs, if you take Laplace inverse transformation, that will be alpha of Laplace inverse Laplace transformation fs plus beta inverse Laplace transformation of gs. Laplace inverse transformation of minus 2s plus 6 by s square plus 4. Break it up term wise, minus 2s by s square plus 4. So this is minus 2, this alpha is minus 2 s by s square plus 4. So that's it, that is minus 2 cos 2t, and this is, you consider this 3 take outside, to 2 by s square plus 4 plus 3 sin 2t. So this is just happening out by linearly t property and fixing up constants. Next, partial fraction. This is also a very important. Laplace inverse transformation of s square plus 6s plus 9 s minus 1 s minus 2 into s plus 4. So here I am giving you one hat, that if in the denominator part you have s cube root type terms, like 3s, if you multiply it, you will get s cube. There is square term, so you need to write it as a by s minus 1 plus b by s minus 2 plus c by s plus 4. Then what you have to do, you have to just, what will be a, this a will be, you need to just multiply them up likewise terms, you equate likewise terms, and these things are quite calculative, and you need to be very careful while dealing these problems, because it may, small algebraic mistake, calculation mistake may lead to fatal problem. So this is s square plus 6s plus 9 by s minus 1 into s minus 2 into s plus 4. If you break it up, you will get minus 16 by 5, 25 by 6 and 1 by 30 as the numerators. Then this up, you know that minus, if you take Laplace inverse transformation, inverse Laplace transformation by linearity property, this will be minus 16 by 5 e ki power t plus 25 by 6 e ki power 2t plus 1 by 30 e ki power minus 40. This will be the answer. Transformations of derivatives. Transforms of derivatives, I will not discuss that. You will just, it is a very brief calculation. So if you know the Laplace transformation of ft, you can also determine the Laplace transformation of f prime t. The Laplace transformation of f prime t will be s into fs minus f0. Laplace transformation of f double prime t will be s square fs minus sf0 minus f prime 0. Laplace transformation of f cube x will be s cube fs minus s square f0 minus s f prime 0 minus f double prime 0. So that is how the thing goes. Okay, so the first two are important, 3 we will use very rarely. So first and 2 is very important. This is the for general n degree formula. This is the general n degree formula. If your f prime up to n minus 1th derivative are continuous and are of exponential order, and if fnt is piecewise continuous, then Laplace transformation of fnt is satisfied by this formula: s ki power n fs minus s ki power n minus 1 f0 minus s ki power n minus 2 f prime 0 minus and so on minus f ki power n minus 1 0. So we will also solve linear ODEs using Laplace transformation, and I think sir has already discussed these things. So these are the flow chart. Find unknown yt that satisfies differential equation initial condition, apply Laplace transformation, transform differential equation becomes algebraic equation, solve transport equation for ys, apply inverse, solution yt of original IVP, you will get it. So this is a problem, you need to use the Laplace transformation to solve the initial value problem. So those who are, I am requesting, please try to solve this problem, solving a first order initial value problem. Okay, so this is Laplace transformation of dy dt, Laplace transformation of dy dt plus Laplace transformation 3 into Laplace transformation of y, Laplace transformation of dy dt, call it capital Ys. So this will be sys minus y0, 3, this is 3 into Laplace transformation of y, so ys, and you have initial condition as 6, so that will be sys minus 6. Then sys minus 6 plus 3ys, which is आप यहाँ पे इसका Laplace transformation, that will be 13 into 2 by s square plus 2 square, so that will be s plus 3ys, this 6 take it there, then ys equal to 6 by s plus 3 plus 26 by s plus 3 plus s square plus 4. You then what you need to do, आप इसको 6s square plus 50 by s plus 3 s square plus 4. Now this s square 4 is not gets factorial by real numbers, so the 6s square plus 50 by s plus 3 by s square plus 4, that you need to write as a by s plus 3 plus b as c by s square plus 4. Now putting the right hand side of the equality over a common denominator and equating numerator gives 6s square 50 equal to as square plus 4 plus bs plus c into s plus 3. Now setting s equal to minus 3 immediately yields a equal to 8. Since the denominator has no more real roots, we equate the coefficients of s square and s. You get 6 to be equals to a plus b, and 0 is equal to 3b plus c. You calculate it, you will get equation, you will get b equal to minus 2 and c equal to 6. Thus ys equal to 6s square plus 50 by s plus 3 into s square plus 4. So that will give you 8 by s plus 3 minus 2s plus 6 by s square plus 4. And now this is just break it in terms of term-wise division. So this yt becomes 8 into Laplace inverse of 1 by s plus 3. From here you will get e to power minus 3t minus 2 Laplace inverse s by s square plus 4. It will get, you will get sine 2t, sorry cos 2t, and here you will get plus 3 sine 2t. So ultimately the answer will be 8 e to power minus 3t minus 2 cos 2t plus 3 sine 2t. Similarly second order IVP, you need to just y prime 3y prime, and you need to just use the algebraic calculation, and then you can also determine the thing. So till now here also there are many problems, there are many problems, transformation of derivative and all, there are many problems, but I hope that you will try at least to solve these problems. There is 0.9 s by s minus 0.1 into s plus 0.2. so how to break them up, आप कैसे इसको solve करोगे, that totally depends upon you. You need to use just partial fraction here. So next up to this we will discuss the basics of Laplace transformation, and up to derivatives we have discussed, inverse Laplace transformation we have discussed. Now we will discuss the problems which were anybody are there? Okay, so now we will discuss the problems. Okay, so these are the tutorial sheet for last year assignments. I think it is last to last year 2021 probably. So देखो, we have already discussed these things, right? So this is also twice you are considering, twice the Laplace inverse transformation you are considering twice. Laplace transformation, so it has two t square derivative, first at Laplace transformation at t equal to 2, the second at t equal to 3. So what you have to do, you have to just, because 0 तो उसका कोई मतलब नहीं है, then this is your first problem actually. This is, you need to determine the Laplace transformation of ft. This is 0, this is t minus 1 by s, this is t get less than 2, this is 2 greater than or equal to t less than 3, and then 7 t greater than or equal to 3. So pass integration of 2 to 3, t minus 1 e to power minus st plus 3 to infinity 7 e to power minus st dt. So that is will give you t e to power minus st by s minus e to power minus st by s square up to 2 to 3, and here also you need to just integrate it, you need to integrate it. So this is here 3 to infinity 7 e की power minus st dt. So that is this is just Laplace transformation of 7, so that means minus 7 e की power minus st by s up to sorry, no, that is 0 to infinity, no, that is 3 to infinity. So 3 to infinity, if you integrate it, and just after the integration you will get 1 by s square e की power minus 2s minus e की power minus 3s plus 1 by s 5 e की power minus 3s plus e की power minus 2s. So option C is the answer. I am just keeping it for your to some minute for your reference. This is, I hope that this first problem is already clear. Just here we have to do integration 2 times. Next problem, ft 3 cos hyperbolic 5t minus 4 sin 5t, then the Laplace transformation of ft. Very easy. 3 cos hyperbolic 5t, from here you will get 3 into s divided by s square minus 25, right, and from here you will get minus 4 into 5 divided by s square plus 25. You just do algebraic manipulations and you will get it to be this option D. This 3 cos hyperbolic 5t is 3s by s square minus 5 square minus 4 5 by s square plus 5 square. So this is 3s cube minus 20s square plus 75s plus 500, that is s की power 4 minus 625, just the option D. This is a clear, whatever I have discussed in our class, this C, the tutorial is just based upon that part only. I am keeping it for 2-3 minutes for your kind reference. Okay, so next we will move to our next problem. Which of the following statement is correct for ft equal to t square? The Laplace transform of ft does not exist. Obviously exists, because t square is bounded by e की power t, exponentially bounded by e की power t. It is piecewise continuous तो है, एक्सपोनेंशियल है, एग्जिस्ट है, तो वेरी इजी बी सी डी. Just easy problem, no need to discuss these things. The Laplace transformation of ft equal to 1 by t, t belongs to 0 to infinity, exist or not? Laplace transformation of 1 by t does not exist, because this integral does not converge for any value of s. So So that's why e keep 1 by t, it does not have any Laplace transformation. Next, this is just a problem based on partial fraction. This is s plus 1 by s square plus s minus 6. You can write it is in the partial fraction. Okay, so this is also breaking into partial fraction. A by s minus 2 plus b by s plus 3. So a into s plus 3 plus b into s minus 2. Now a plus b equal to 1, 3a minus 2b equal to 1, a equal to 3 by 5, b equal to 2 by 5. Laplace transformation of ft will be 1 by 5, 3 by s minus 2 plus 2 by s plus 3, 3 e ki power 2t plus 2 e ki power minus 3t. So that will be the answer. The answer is t. Next problem. The inverse Laplace transformation of 2s plus 3 by s square plus 9 is 2 cos 3t plus sin 3t, cos 3t minus sin 3t. Same problem, just 2s plus 3. Linearity property of inverse Laplace transformation we have already discussed. So this 2 into L minus L inverse s by s square plus 9 plus L inverse s by s square plus 9. So from here you will get cos 3t, from here you will get sin 3t. So to note down, I am keeping it in for 2 minutes. Just I am coming. Just give me 2 minutes. Okay, so next move to the next problem. The inverse Laplace transformation of 3s minus 2 by s square minus 4s plus 20. Once again, see how you will solve. Take this 3 outside. Okay, आप क्या करोगे यहाँ पे, you need to 3s minus 2, subtract minus 4 and plus sub 4, so that will give you 3 Laplace inverse s minus 2 by s minus 2 whole square plus 4 square plus Laplace inverse 4 by s minus 2 whole square plus 4 square. That will give you 3 e की power t Laplace inverse s by s square plus 4 square plus e की power 2t Laplace inverse 4 by s square plus 4 plus. And then from here on you will get 3, this e की power 2 is there, because that's why this minus 2 term is, this is the first shifting property. So this is s by s square plus 4 square will be give you cos 40, and here you will get sin 40. Both side e की power 2t is there, so you take e की power 2t common, you will get 3 cos 40 plus sin 40. Next problem. Next problem is the Laplace transformation of t e की power minus 2t sin 3t. So देखो, this is second shifting property. What is this? Laplace transformation of t की power n ft is minus 1 की power n ddn ds and fs. Okay, so we will determine Laplace transformation of t sin 3t first. So Laplace transformation of t sin 3t is minus 1 dds by 3 by s square plus 9. So that if you integrate it, derivative it will get 6s by s square plus 9 whole square. And then there is t e की power minus 2t sin 3t. So you, instead of s, you need to substitute as s minus minus 2, that means s plus 2. So the answer is 6 into s plus 2 by s plus 2 whole square plus 9 whole square. So the answer is A. I hope that it is also clear. I am keeping this for 1 or 2 minutes just for your reference. Okay, so ninth problem, the Laplace transformation of the integral 0 to t u square cos hyperbolic 2u du is, अरे बाप रे so Laplace transformation of integration 0 to t u square cos hyperbolic u. So if you integrate it, how to do? Okay, so cos hyperbolic t squared is e की power 2t. This is 2 by s minus 2 whole cube, and this is t square e की power minus 2t. 2 by s plus 2 whole cube. So this is integration of this. Okay, so how to do here? If there is integration, I think that Sir has something taught called convolution theorem. This is actually application of that. This is 0 to t u square cos hyperbolic 2u. So for integration sign to vanish, you need to sacrifice 1 by s here. So then it is t square cos hyperbolic 2t. Then cos hyperbolic 2t, you know cos hyperbolic 2t. Cos hyperbolic 2t, the integration will be Laplace transformation will be next. So here up cos hyperbolic 2t का last जो what I have discussed, that t की power n into function of t, so that means minus 1 की power n ddn dsn fs, that also you can apply. So that is t square cos hyperbolic 2t. The Laplace transformation of cos hyperbolic 2t is s by s square minus 4. Now you can take minus 1 square d square ds square, that two times derivative of that integration, that Laplace, so you will get the same answer. This how transformation happens, I just forgot, but I hope that there is some rule to channel it out like that. Okay, so next problem is using Laplace inverse transformation for s by s square plus 9 whole square, that is 1 by 6 t sine 3t. The inverse Laplace transformation of s square by s square plus 9 whole square. Okay, this is also a very interesting problem. So Laplace inverse transformation by s square plus 9 whole square is 1 by 6 t sine 3t. This is equal to ft. Now Laplace inverse of sfs. So up you got ft. Now what is your f0? Your f0 is 0. Now Laplace transformation of f prime t will be sfs minus f0, that means 0. So this is nothing but sfs. So s square by s square plus 9 whole square. So Laplace inverse transformation of s by s square plus 9 whole square. So this is ddt of Laplace inverse s by s square plus 9 whole square. So this is ddt of t sine 3t by 6. The derivative of that function. Now derivative of that function will be, आप derivative लोगे तो that will be sine 3t by 6 plus 3 into t. You will get it from here cos 3t. So 3t cos 3t. So that is how this things works. So we have discussed many problems such as Laplace transformation of derivative, inverse Laplace transformation, and many more. So that's all for today's class. We will wrap up the Laplace transformation in the next class, when we will discuss about convolution theorem and all. So if anybody does not have any question, then I will just wrap it up today. Any question? I have already uploaded these notes in the NPTEL portal. Any question? Anybody joined? Anything that you want to give me some input? Okay, if not, then thank you for joining. Saranya Mohan and Dr. Ravi Kumar sir, thank you for joining.